So right now what you see right in my screen is the list of topics that we are going to cover in this training. Go ahead and mute yourself, all of you. Please go ahead and mute yourself. So it is a basically it's a full DevOps training, DevOps plus AWS training. Basically, we are covering almost everything a DevOps engineer need to know, starting from the basics. We will actually beginning in the beginning of our training, we will cover some Linux basics. If you are new to Linux, right, you will get a good idea on Linux operating system, some commonly used commands in Linux, and also how to create usages in Linux and how to give permissions. These are some basic Linux topics that we would cover initially in order to get you started with Linux. And I request, even if you know Linux, I request you to take this training so that you will get a clear idea where you need to begin. And once we are done with the Linux basics training, we will move on to advanced Linux administration training. This is the place where we are going to talk about the softwares, the web applications. You know what an web application is, right? So how you can set up a software or a web application in a Linux environment, and how you can serve this software to your customers over the web on a HTTP URL, and how you can register your own website and run this web application on your own website and make that website available to people on the internet, and how this web application can communicate with a database. So these are the main topics that we are going to cover in the Linux administration training. You will get a clear idea about the Linux environment and deploying these web applications into the Linux environment once we are done with this part, which is one of the most
Sorry to
important
disturb
parts.
you.
Go ahead.
Hello?
Yeah, go ahead, Madhuri.
Yeah, sorry to disturb. Yeah, it's Madhvi. Sorry to disturb you. You are telling like how web application. You are taking the name so many times. So actually, I am from middleware, so I don't have that much idea like what is web application
A
and
web application is something, yeah, I will describe. A web application is
and
something that you can browse over a web. It is a software, a type of software that
okay.
is available to you over the web. Google.com is an example. You browse
Mm-hmm.
Google.com, you get the web application of
Okay.
Google. You can perform your
Okay.
search
So
function and get the search result.
do we need to have do we need to have web application knowledge also for this one, or it's like just if we know what is web application, that is fine?
Basically, we need to know what is a software. The DevOps is all about taking care of the life cycle management of a software. And normally, some 80% of the softwares are web applications. So we are taking web applications as an example in our training. And on top of that web application, we will, when you want to build a infrastructure where you want to run this web application, or when you want to implement our DevOps principles, the continuous integration or config management, we would be taking this web application as the sample software. So
Okay.
that is why it is not absolutely important, but you need to know this. What is this software? What is a web application? It's important for you to know before you begin with your DevOps journey. So that is the reason we
Okay,
are
but
covering
you
this.
will be teaching, right? What is samples of web applications or
Yes,
something
we
like
will actually take
you'll be
two web applications, one written in PHP and another one written in Java. We will not focus on the
okay.
coding part or anything. We will focus on deploying these
Functional.
applications into a Linux environment, and we will see how it works and all, and how it can connect
Okay.
with the database.
Okay, fine.
So this understanding you need to have before you begin with DevOps. So even not just Linux administration, some networking basics also. The basic networking skills also you need to have, and that's what we are going to cover next. These two are the most important topics. I mean, don't think that this is the basics before we start with DevOps. Actually, this is part of the training. A DevOps engineer need to know all these topics in detail. Under the networking, we will cover under the networking we will cover the topics like DNS, how the DNS resolution works on the internet, if you have your own website, how you will register your own website and run your web application in this website, what are all the steps that you need to take care, then how you set up a network in a traditional office infrastructure. So these are the things that you need to know, especially before we learn cloud computing. In cloud computing also, actually, even though we are not dealing with the router devices or networking cables, we are not dealing with that, but actually as a service, the networking in cloud is same as the traditional networking. It has the same structure as the traditional networking. So you need to have a good understanding about today's networking infrastructure that you would use typically in a office network or inside a data center. So that is what we are going to cover under the networking basics. So these topics need to be completed. We will also cover some troubleshooting, how you would do some troubleshooting if you find any problem with the Linux machines or any network connection issues, how we are going about troubleshooting those issues. Those things we would be covering. These two are most important topics before we begin with the advanced topics. And our advanced topics are cloud computing and DevOps. Cloud computing, we are focusing on Amazon Web Services, or in general it is called AWS. Windows we would not be taking. Actually, our entire course would be much more focused into Linux, not too much into Windows. Make a note. But it doesn't really matter. I mean, DevOps is not specific to any operating system. That you will understand once we are done with today's class. But in our course, we would be taking mostly working with the Linux operating system, and also Linux knowledge is essential because most of these DevOps tools, some of these DevOps tools that we are going to learn, they run only on Linux. So you need to work on Linux anyway, whether you want to manage Windows machines or not. You definitely need to know Linux. So that is the reason our entire course would be mostly focused on Linux. But it doesn't really matter. DevOps principles are generic, not specific to any operating system. But yeah, we can talk about if you can bring up with your questions, we can discuss about how we can do the deployment into Windows. Yeah. And so these are our advanced topics, cloud computing and DevOps. So we, in the meantime, someday we would be covering, actually we would be covering this towards the end of the training, shell scripting and Python, basic Python programming. So you need to know some scripting, even though you do not do any software development. That is not your job. That is the job of your developers. But still, you are someone who need to do some scripting when you want to do some kind of automations. So scripting is important, especially the shell scripting. You need to work with a lot of system operations, and you need to work a lot with shell scripting, but not very big script. We are covering whatever you need to know, right? You don't really need to learn anything from extra. And Python programming also, we are covering the basics, not the basics actually. We are covering only the essential topic that are required for DevOps, mostly the modules and object-oriented programming is what we are going to focus on Python programming. It's a detailed training, basically, mostly how you can integrate third-party tools with your systems is what we would be. Basically, there are few things which you cannot do with shell scripting. For example, you have a third party, a cloud computing provider, and you want to create a machine inside that cloud computing provider. And that cloud computing provider support only Python program, right? Only using a Python program, you can do the automation. Maybe you want to create a machine inside that provider automatically. Your only option is Python program. So there can be some situations which we will discuss in detail when we learn Python. So there can be some situations where shell scripting will not fit, and you would be forced to use Python because Python is such a popular language that nowadays every third party support Python. That is the advantage with Python, and that makes Python one of the favorite language for DevOps engineers. It doesn't really matter which language you write your programs in. It doesn't really matter actually. It would be up to you to choose which programming language you want to use when you want to write a program. There won't be any specifics like you are developing a Ruby software, you need to write the code in Ruby. There is nothing like that when you work as a DevOps engineer. It would be mostly automation tasks that you want to write, and it's up to you. You are flexible to choose which programming language that you want to use. So these are the two programming languages we will be covering in our training in pretty much detail. Basically, you don't really need to learn anything from outside on the scripting part. But on the Linux part, if you could learn more Linux topics, it would be always great, especially since you are from India. When you take a DevOps interview, you could also expect some Linux questions. So I will let you know what all things that you want to learn in Linux. If there is something extra, all those things I will let you know. Along with we do, they would come as assignments. Read some tutorials and everything. So once we are done with this basics training, I repeat, these are the most important training before we begin, because we are going to talk about these PHP applications, Java application, database connection, the networking principles. All these things we are going to talk about later when we learn cloud computing and DevOps. So it is important that you do it very well. Okay. So about the cloud computing, I will just first give you an overview about cloud computing. What is cloud computing and what is our course plan in cloud computing? Okay. So what is cloud computing? Think about this. You want to run a software. Think about google.com. How you browse google.com? This is you from your laptop. You open your browser, browse google.com. Then you will connect to some machine on the web, which is nothing, a machine part of Google's infrastructure. And this machine will serve you the web page, and that is how you get the web page displayed in your browser. Right? You are getting the google.com page from a remote machine, and this remote machine is owned by Google. Maybe this is a machine part of Google infrastructure, and like that there can be multiple machines in Google infrastructure, right? Not just one machine. Maybe sometimes you search for google.com, you hit this machine and you get the page from this machine. Then you are searching for some time, you want to search for something in the search box of Google. Then what this machine will do is, the machine does not have the search algorithm running inside that. Maybe it is a different machine which is running the software component that takes care of search algorithms. So what this machine will do is, it will send whatever string which user had entered in the search box. That string would be passed to the other machine, and this machine will run the search algorithm, and it will finally create a query for that particular search algorithm. Then it will connect with a database and run the database query on this database, and the web page you will get, and this machine will finally display the search result into your browser. So maybe what I'm trying to say is, there can be multiple machines work together in order to serve you your request. In Google's infrastructure, there can be multiple machines that work together in order to serve you. That is the case with any company. Think about Flipkart. One machine would serve you the Flipkart front page. The other machine would be responsible for creating the shopping cart. This is the machine that will take care of the payment gateway, connecting with the payment gateway and making the payment. And this could be another machine that would take care of the user login. So there can be multiple machines that work together in order to serve you a web application. And every startup who has a software need such a infrastructure, right? Generally this is called a production infrastructure. It's called a production infrastructure. Over there you can find multiple machines, not just the machines. These are some Linux machines, maybe these are some Windows machines, and these are some database devices, these are some networking devices. Like that, there can be multiple devices that you would find inside a traditional infrastructure. They work together in order to serve you the software. And every startups or every company who owns a software needs such an infrastructure in order to serve their customers. Not just Google and Flipkart, any companies who has a software, they need to serve this software through a infrastructure, and generally it is called the infrastructure which would be available to the market. I mean, people who is in the internet, they connect to a particular infrastructure and get themselves served. Those infrastructure is generally referred as production infrastructure. So if you have to set up such an infrastructure for yourself, it's not an easy task, right? You need a building, right? You need a building in a good place, and you need a lots of machine. You would purchase a lots of machine and keep those machines inside the building. Then you will set up a very good ventilated AC to make sure that it never get heated up. The machine should not get heated up or anything. Then you need good power backup, multiple UPS that would give power, and you need highly costly switches and networking routers and NAT gateway devices. Then networking cables, you would connect all the networking cables together, and the machines would create a infrastructure, and that is highly costly. The building itself would cost you a lot. The rent of the building, the internet connection, you want connection coming from multiple providers because you cannot afford the internet going down inside your data center, right? If something happens, it could be the worst thing that you can do to your software. Basically, if the internet connection is down, your software would be unavailable to people. That is not something you can afford. So you want highly costly network connections from multiple providers. You need very good advanced UPS devices. So all these things are a requirement if you have to set up everything, and which would cost you a lot of money. So the companies, due to various reasons, these are one of the main reasons, they does not prefer to set up their own infrastructure. They would generally rely on a third-party cloud computing in order to deploy or build their infrastructure in the cloud. That is where cloud computing come into picture. I'm not audible. Am I not?
Now we can hear you.
Okay.
Yeah, now we can hear you.
Okay. Which part you missed? You missed some time or just a glitch? Okay.
You were talking about this.
Yeah, what I was trying to say is if you have to build your own building and internet connection and everything, it's going to be highly costly. You need a powerful UPS devices so that there won't be any power problems. Then you need to install the necessary security measures so that there would, if there is any fire or something, it is auto prevented. Hello? Yeah, actually I got disconnected again. I don't know why it is. Yeah. Okay. What I was trying to say is if you have to build your own infrastructure, there are lots of technical problems which you would experience, lots of physical security that you need to take care, lots of power backup solution you need to take care, lots of internet connection you need to take care, right? They will be highly costly because they need to be very much good in quality. You cannot afford your internet going down in the data center. Think about that, right? Your internet is down, then people cannot access your web application, the worst case scenario. So these kind of situations you want to avoid. So what nowadays people does is they rely on a third party cloud computing provider to build their infrastructure. AWS is the leading cloud computing provider today. So what these guys will do is they will have these data centers all over the world, maybe some 14 or 15 locations in the world. They will have data centers and they will virtualize their data centers in such a way that they will give all these things, the network, the machines, the databases, the Windows machines, Linux machines, whatever that you want to be part of your infrastructure, all these components, they will give it as a service. For example, you want to create a network. What you can do, you can browse the URL aws.amazon.com, then you can log into their website. You will get a dashboard. There you have an option to create a network. You click on some button to create a network would be created. Then you want to split this network into small subnets. Then you click on another button, create subnet. Then small subnets are created inside this network. Then you decide that you want to create a Linux machine. You click on some another button to create a new machine. Select your operating system as Linux. Then click on select your how much memory, CPU, hard disk you want. You select everything, and your machine is created inside this network. You want to create multiple machines, you can create multiple machines. You want to create some storage devices, you can create storage devices. You want to create some database, you can create some database devices. Like that, whatever services, whatever things that you want to create as part of your infrastructure, you can create them just by clicking on some button in the cloud computing provider, and you get all these things as a service. Maybe these are not actual machines that you are getting created. You want to create a Linux machine, you click on some button, select Linux operating system, click on create machine. The Linux machine is created within 2 seconds. Even though this is not a real machine, actually, AWS, I told you, AWS will do some kind of virtualization. I don't really care. I will tell you how they do that when we learn cloud computing, but assume they did some kind of virtualization in some way so that what you get is a virtual machine. It is not a actual physical machine, but you don't care. It will look like a physical machine, and you can run your software inside these machines. So you can build an entire infrastructure in the cloud, which will look like a real-time infrastructure, and you can run your software inside that, and this infrastructure will serve your customers. So you get all the advantages and many more. Actually, you will get many more advantages. For example, you want to back up a machine, you can just take an image of the complete machine, then use that image to create multiple other machines. So you get a lot of flexibility, load balancing, there are many things, many flexibility that you would get when you go with a cloud computing, and the cost would save very considerably. So in our project, in our training, our plan would be build an infrastructure in the cloud where we are going to deploy our software. We are going to learn two applications, PHP applications and Java application when we learn Linux administration. This application that we had learned, we will deploy them into this cloud infrastructure which you will design. And this infrastructure will be highly available. It would be scalable, and it will be fault tolerant. I will tell you what these terms are. So you need multiple machines created across multiple subnets when you deploy your software into this infrastructure that you design in the cloud. Your infrastructure will be highly available. What does that mean? You are going to set up your PHP application in 2 machines, Java application in another 2 machines, database in another 1 machine. Then this is the database replication machine, the slave machine. Then here, this is the storage device. This is the monitoring machine. So like that, there can be multiple machines that you will have inside your infrastructure. And your software that you deploy inside that, let's say this is some guy who browse for your web application, they will connect with one of this machine, get the front page, then they want to log into the machine, it will connect to the other machine and get the user login. So there can be multiple machines working together in order to serve your software. So to these people, your software would be always available. That's what I mean by highly available infrastructure. What is mean by the software would be always available? Basically, no matter what happens within your infrastructure, maybe some machine can go down. It is unpredictable at any point of time. You cannot, it is internet and it is networks. So far, there is no predictability in today's internet. Any machine can go down, any network can go down at any point of time. So the term high availability means no matter what happens inside your infrastructure, maybe the machine can go down, maybe some service running inside these machines can go down, your software would be always available to people. So you will decide the infrastructure in such a way that even if some machine goes down, it will not affect the softwares. And scalable is another property that your infrastructure that you design will have. Scalable means sometimes the traffic can grow inside your infrastructure. Maybe right now only 1,000 people are browsing for your website, and next week it would be 2,000. And maybe some particular day you are doing some campaign, think about Flipkart Big Billion Day. So Flipkart would be getting maybe 5 times more traffic on that particular day than the normal. So in such situations, whenever there is a campaign going on, or you are expecting a lot traffic hike in this environment, then the machine that you currently have will not be able to handle that huge traffic because unexpected traffic is coming. what your infrastructure will do is, it is designed in such a way that when the traffic increases, it will add additional machine into your infrastructure automatically that will start handling this traffic. So it would be more like a self-serving infrastructure, which would add more machines whenever the traffic is increasing and delete the extra machines whenever the traffic is back to normal. So AWS has pricing policy like you pay only for the hours that you use. It's hourly billing. It's not monthly billing, not daily billing. It's hourly billing. So if you create 100 additional machines into your infrastructure and use it for only 5 hours, you need to pay only for 5 hours, not for the entire month. So you have this flexibility, pay as you go option in AWS. So scalability is an ideal option which AWS provides you. You can rely on some of the services inside AWS to achieve this scalability. So you need to pay for only what you use. So the traffic is growing, yes, create additional machines. You don't have any option. When it is back to normal, delete them. So that you can save a lot of money. And fault tolerance is also some feature actually that we will get it. If one machine goes down, the other machine will come as a backup. It will replace the other machine. So these are the three features that we are going to implement in the infrastructure that we are going to design. And this is like a live project. Actually, this is a project that I work in, right? It's the similar project that we are going to do in our training. And even though I won't be giving the project code, we would be taking this sample PHP and Java application that we had learned as the software that we are going to deploy inside the infrastructure that you would build. So there are different services. EC2 is one service where you can actually get Linux machine or Windows machine from AWS. Elastic load balancing is one service from where you can create load balances. So like that, there are different services that we are going to cover. And as we learn more and more services, your project will grow, right? It is not a one-time project. We will start the project after we done with the first 4 services. Then as we learn more and more services, you will add more and more component and features into your software. So by the time we finish AWS classes, you would complete your project. That is the plan. So make sure that you find time to work on this project, which is very important. Okay? It's very important that you finish the work in time. Otherwise, if you pend it to later, you will forget things. That is one disadvantage, because we are actually learning a lot of things in a short period of time. So the practical should go along with our training, which is very, very important. The project need to be finished along with we do the classes. I will let you know what all things you need to do. Hardly you need to spend maybe an hour to finish this work. Yeah. And then we will move on to DevOps. These are the different tools that we are going to cover under DevOps: Git, GitHub, GitLab, build management, Jenkins, Docker, Nagios, Chef, Puppet, Ansible. These are the different tools that we are going to learn. And finally, we will have an overview about some other tools out there in the market, and also we will discuss about some interview tips, how you explain these projects to the interviewer. There are 2 more projects that we would be doing under DevOps. One is under infrastructure config management. The other project is continuous integration. So 2 projects also we are doing along with we learn DevOps training. And like I said, this is also something you have to do it alone. I will make sure that you are getting enough time to complete it, but make sure that you are doing it while we are doing the course. Don't pend it to the end. It would become confused. You would be confused. And finally, we will have a interview, interview preparation training and resume preparation training that we will have towards the end, and how you explain these projects to your interviewer. All those things we would be discussing at that point of time. So about the DevOps tools. The first project that we are going to do is under config management, and these are the tools: Chef, Puppet, and Ansible. Actually, all do the same function. Architecture wise and functional wise, the functional wise all tools are same. The architecture wise they are different. Chef and Puppet will have similar architecture. Ansible has little different architecture. So in our training, Chef we will cover in depth, but in your project you can choose any tools. Actually, you would be covering Puppet and Ansible also, how these tools can replace Chef, All these things we will discuss. So when you do the project, it's up to you to use whichever tools that you want to use to finish your project. So I will tell you what is config management. So think about a production infrastructure that we discussed about. It contains a number of machines, right? Depending on the usage of your web application or your software, there can be a number of machines inside your production infrastructure. So when you have a lots of machines in your infrastructure, it would become impossible for a human to remember these machines and remember what software component need to be installed in these machines and how each machine should look like, right? Maybe you want to copy some files into these machines, you want to create some uses inside the machines, you want to install a set of software in the machines, then the application code you want to copy deploy into these machines. There can be a certain thing that you want to do in each and every machine in your infrastructure, and assume there are hundreds of machines in your infrastructure. If there are up to maybe 5 or 10, you would be able to handle it of your own. But if there are more than those many machines, you cannot even remember which are the machines and what software component need to be set up in each machine. So rather than humans managing this such big infrastructure, you would configure some tools which will take care of the configuration. You write down how the configuration in each machine will look like. That would include what software component should be installed in the machines, what file and folders should be present in those machines, which uses should be created inside those machines, what process should be running inside those uses, which services need to be started. So a set of checklist you would write down inside this config management tool. And sometimes you will group all these machines. Maybe all these machines are running the similar software and all machines should look alike. So in such situations, you apply this checklist to this group of machines, which means each and every machine will run this checklist and make themselves up to date with whatever you mentioned inside this checklist. And that would be applied for your entire infrastructure. So basically, you write down your entire infrastructure inside this config management tool. It can be Chef, Puppet, or Ansible, whatever it is. You can write down the configuration, how many machines you have, how the machine should be grouped, and what are the checklists that you need to run on each group. So all these things you would write down inside this config management tool. Then in an automated way, the config management tool will start handling your infrastructure. If you want to add a number of machines, I want to add some 10 machines. I will just create the machines, add the machines into the respective group. Then automatically, this config management tool will detect that, okay, this machine belongs to this group. Then I will install this particular software inside those machines because the checklist for that particular group would be applied on those machines. The software that are required would be installed on the machines. A service that need to be started would be started on the machines. The file that need to be copied will be copied on the machine. So basically, the machine would be set up from the scratch as per whichever group they were assigned to. So basically, your entire infrastructure would start being managed by a tool instead of human. So your responsibility is only writing down if there are any change in the infrastructure. You write that inside your config management tool in a single place. Then your entire infrastructure will check these configurations and update themselves with the latest configuration that you wrote inside config management. So that is what a config management is. So in the previous project, you would build an infrastructure. I told you would build an infrastructure that has multiple machines. Then these software component, the PHP application, Java application, whatever software that you need to be installed, you would install it all manually inside your machines. This time, you set up your config management tool, and this tool will build the infrastructure for you. You will not do any manual work. All you do is just click on some script or run a single script in the config management tool, which will build your entire infrastructure. So that is going to be your next project, the config management, one of the most important topic. Actually, that is what define how DevOps would differ from the traditional system administration stuff. The operations moved into a code. In today's world, the DevOps way is the infrastructure are not managed using the traditional system administration. It is actually managed as a configuration, or it's managed just like the developer would manage the code. So these are some uh, principles which we will actually implement using one of these tools. That's our second project, and we will have our final project, continuous integration, combining all these things and also some other tools also. So I will tell you what is continuous integration and what we are going to do. This is the third project. Total we have 3 projects. This is the third project. So think about this. I think though many of you are from testing background, so I will just explain probably what you're doing and how DevOps would improve this process. So think about this.
Basil?
Yeah.
Hello? Yeah, Basil, is there any certification that we have to do to showcase our resume? I mean,
For
because I want
DevOps, you
to,
don't need any certification. Actually, there are no
because
also
my colleagues were telling me
automatic
like, we
certifications.
should like ask for. Hello?
Yeah, and what I said is for DevOps, you don't need any certification. Actually, to be honest, there are no good certifications for DevOps yet. There are some institute certifications, but not. DevOps is still not something. I mean, if you define ask what is DevOps to 10 people, you would get 10 answers. So, DevOps actually covers as a whole, starting from the requirement analysis till your software become available to the production. So whatever happens in between these two, if there is a series of process. DevOps covers it as a whole. The complete software lifecycle development flow is what DevOps is focusing on. So you cannot do that as a single certification. It could be, I mean, maybe it would come later. Right now, there is no a right definition on what things you need to focus on when you want to learn DevOps. And that is still right under progress. So in AWS, there are some certifications. There are some good certifications which AWS offers. You can focus on solution architect or SysOps engineer. These are the 2 certifications that you
Okay.
can focus on.
Could you please help us to finish this? I mean, I just want to do some certification also, like with this course. So, will you be able to help us with this?
We will not be taking the certification specific training in our class, but I will tell you how to do that. Basically, it's nothing. You will get some online courses from linuxacademy.com or cloudacademy.com. There are many online video tutorial websites. From them, you can get a free trial. Some 7 days free trial you will get. You can get a free trial and take the course immediately. So first finish our training, and most of the tools for solution architect as well as SysOps certifications, most of the services we are covering in our training. So after you finished this training, taking an exam tutorial would be very easy for you. You can complete in 2-3 days. Then you can write the exam. You will pass. It is not very tough exam for AWS certifications. But you need to go through the exam specific tutorials before you write the exam. Doing our training alone will not help you get the certification. Our training is not exam focused. Okay, so we will talk about continuous integration. So think about this. Think about any software, and for any successful software in the market, the software should be offering the latest, whatever your customers are looking for, right? Your software should offer whatever your customers are looking for. Then only your software would become more and more popular and become success in the market. That is the most important thing. Making changes to the software in time based on the customer requirements. So you can continuously get feedback from your customers. Then based on what feedback you are getting, you can make changes. So think about a company, think about any company who has a software product and they want to make changes to the software. There would be different team. Some marketing team, assume this is a cab application, right? This is some cab application which your company is managing. Using this application, people can book a cab and they can travel in the cab. That's what your software is. So your company is very keen on the software and they want to make sure that the software is outstanding in the market. How you will make the software outstanding in the market? By adding more and more features to it. It is a continuous, never ending process to add more and more features into your software product. When you add more and more features to the software product, your software product is getting more and more complex and the problems can start increasing as well. There can be some issue, some bugs your software would start showing as it become more complex and you need to take care of that also. So think about such a company who has a software which is in the growing state. It's a cab company. They have a cab application using which people can book a cab like Uber or Ola. So the marketing team he found that there are lots of people out there in the market who has Paytm balance in their mobile phones, but they don't have money in their wallet. So he believes that if we add this Paytm payment option in the cab application, that would increase the sales by some 10%, because there are many people, they can book the cab only if there is a Paytm payment option. So the marketing raised a change request, or generally it is called CR or change request, saying that we need Paytm to be integrated with our cab application so that people can book a cab using Paytm. Then at the same time, the testing team, when they tested something, let's say they tried to do some booking from Bangalore location, some geographic testing they did, and they found that people from Bangalore are not able to book a cab due to some reason. Even though the cabs are available, they are not able to book a cab. So it has to be some problem with the application. So please fix that. Requesting developers to fix something, the testing team raised a change request. So like that, change request would keep on coming in. New features, right? The customers want to be able to chat with the driver, send a chat message to the driver. Then the application will automatically read this message to the driver in through a automated system, so that a driver can hear the message, driver can respond by voice, then the application would convert the voice into text and send it as a chat back to the passenger. So some kind of new feature you want to implement, and that request also came from some stakeholder. So lots of change requests would keep on coming, basically from different stakeholders asking to make changes into your softwares. And it would be all these requests are received by developers. These requests would come through web or something. I'm not going into that. So there would be some developers who would receive this request and they will start working on what they need to do. They need to make some code change and implement this new feature into the application. That's what they want to do. So typically there would be a storage device somewhere in the office premise, maybe a repository. You can generally call it a repository. This is getting the changes done by developers. Developer keep on making the code changes. Let's say this is Tom. he is working on the Paytm feature. He is trying to add the Paytm feature into the application. So he need to make lots of change in the source code. Source code is nothing but the code written by developers who developed the software, right? So changing the software would mean changing the source code. So you need to make some code change. Tom would make the necessary code changes to integrate this Paytm option. Then he will, whatever change he has made, he will update those changes into a central repository, and every developer do the same. As they finish their work, they will update their change to the central repository. So basically this repository will contain each and every change done by all developers, and it will contain the latest code also. So whatever change developers does will be copied into the repository. And I talked about this production infrastructure. This is just a storage device where you are saving the code. And I talked about this production infrastructure. These are the machines that would serve the software to your customers, people who try to book a cab from their mobile phone. The request will come to one of this machine, and this is the machine that confirm the booking. Maybe the machine work with other machines also. So any software component, maybe this guy is trying to make a Paytm, then the Paytm change which Tom had done need to come to the production. Unless it is available in production, the people will still not be able to see the Paytm, of course, right? Whatever change developers are doing, it need to come to the production infrastructure. Then only you can say it would become available to the market. Otherwise it is not available to the market. So the release process is what you need to do. Every company does this release process. Through this process, they will copy the code in the repository into the production infrastructure so that it will become available to the market. And this is not an easy process, actually. The reason is there are various teams involved in this process. With each teams has different interests. For example, there is a operations team. Their responsibility is to make sure that this infrastructure is always stable and available to people. Of course, only they know the importance. If the software become unavailable, they are the ones who get the heat. From the marketing team, from the business team, from the management, they are the ones who will get the heat. So they want to make sure that the software is available to people, the production environment is up and running. That is their main concern. They would even sacrifice not doing a release if they believe that the release would cause any harm to the existing software product. In fact, that would delay the release process. And the developers on the other side, they don't know what operation team are doing at all. They want whatever change that they are doing, they want these changes to be moved into the production as soon as possible, which is again a conflict of interest with ops teams. And there is testing team. What this testing team do is they will do some testing before the code move into production. First, you would prefer this code to be tested in a testing environment, right? So probably it will contain a number of machines. It will run the same software as the production would run, but this infrastructure is only available by your testing team, right? It is only internal to your office. It is not directly connectable by people on the market. So this is just for testing purpose. So first you copy this code into this environment. Then your testing team will do some testing, maybe using some automation tools or doing some manual testing. They would perform some testing, and they would, whenever they found some issue, they will report the problem back to developers. Maybe they are doing the testing after 1 week since the change were made. So after 1 week, a report is generated by the testing team and it is sent back to the developers. And when developer verify that report, they found that, okay, the credit card system is broken. They found that the credit card system is broken. So they want to fix it, but they have no idea where this issue come from, because it's been 5 days right now. So there are many developers who made lots of change in the repository, and they have no idea which developer change caused this problem. Maybe the Tom who made the Paytm fixes, while he was doing the Paytm fix, by mistake he modified some component which your credit card system work with, but he wouldn't really remember. I mean, he what he would assume is, generally what a human would assume is, I was working on Paytm integration. There is absolutely no chance it could break the credit card system, but it can happen. So these kind of issues generally happens in every companies, and people will have tough understanding the problem, and even identifying the problem itself would take time. So this kind of unplanned work would delay your release process, and people are not able to bring the changes in the repository into the production in the right time. That is one big problem every companies are facing. Due to these conflicts of different teams, you are not able to do the releases in time. What is the ideal thing that you want to do? You found something need to be implemented in production, you ask your developer to do it, then within no time you want this change to be moved into production. That's what you would want to do ideally. But in real time, it is actually 1 month, 2 months. There are still companies who do releases every 6 months. That means, think about it. You believe that Paytm is a big option that would actually get you huge revenue, and developer fix that, and after 2 months only you are doing the next release. So for next 2 months, it is not in the market, the Paytm change. For the developer, for him, all it took is just 1 week to finish the work on the Paytm. But it need to wait for 2 months, because the next release is after 2 months. Maybe after 2 months, it would not be relevant at all. The Paytm would not be a relevant option at all, because there are new products that came into the market replacing Paytm. Right? These kind of, so basically, even today's market is so tough that within few months, the available features that you have in your product would become useless. So it's absolutely important today that whenever you make some change into the software, you make this change available to the market. So these issues have been growing as the software was growing. So people wanted to find a solution, and actually DevOps came as a solution to this problem. Back in 10 years, people actually realized that they are coming to a dead end, right? There is no way move further, because you are getting 80% unplanned work than 20% proactive work, and that ratio is ever increasing. So people really realize that this is not the way of working. There must be a better way. The better way is actually the teams working together towards a common goal, developers and the operation teams. By developers, I would say the testing team, the development team, marketing team, all these guys. The operation teams, the ones who takes care of this integration process. So they will work together towards a common goal. The common goal is build a pipeline for the software development process. It's something like a traffic in the road, right? As every cars are moving, it's all looking good, right? As every cars are moving, it is making the other car to move on. So this way, the changes will flow like a pipeline. Whatever change a developer is doing, let's say this is a developer, he is working on some issue, he fixed his change, he added the code into the repository. Immediately, as any new change come from any developer, the code would be taken from the repository. It will be built into some executable. Actually, the plain text code is not a usable code. It need to be converted into some executable code, then only you can use it. So that process is run, and it created some executable files out of the source code. And these executable files are kept inside some repository, some storage device. And then these executables are deployed automatically into a testing environment, and a automated message would be sent to the testing team as well as the automation testing tool, which will in fact start doing the testing in this infrastructure, creating a report about this testing. And it will again automatically verify this report. If there are any errors, an email would be sent to the right developer who made this change. If it's all looking good, the report is looking good, then automatically this will be marked as a stable change, and this change would be moved into a stable place. So this is a place, a repository, or maybe a new branch in the repository, which no need to focus. Just this is a different storage device that would get only the changes which are stable. So if the report is looking good, this change would be copied here. So this is a place that would actually contain only the stable changes. If there are any error, the developer would get the feedback, within minutes. So all these things are done in a completely automated way through a series of pipeline process. So developer get the immediate feedback. Whenever there is a problem, they get an email maybe within minutes, and then they can easily identify, okay, credit card system is broken, then probably it was working 10 minutes before I made the change, so it has to be a problem because of my change. They can easily predict the problem, they can fix it. So basically the aim is to find out the problem in the very early stages of development. Apart from you do the testing after 1 week, any build step has failed or any uh, testing has failed, whatever it is, the problems are detected in the initial stages of development. As the developer make a commit, all this process would. So for each and every small change which each developers are doing, this entire pipeline will repeat for each and every change. So it is more like a robust, you got a good confidence that this is going to work, because by the time you do the release, maybe tomorrow you are planning to do a release, every day you are planning to do a release, so within every day this series of pipeline get executed maybe multiple times. So your software is getting tested and tested again and again, each time a new change is done. So this is called continuous integration, and as the changes get stable, they are moved into the other stable place. This process is generally referred as continuous delivery. This is called continuous integration. Each change done by developer being verified in a through a series of pipeline process. So this is going to be our project CI/CD pipeline. This is what we are going to cover as our project, one of the most important project in our training. We will take those PHP and Java applications as the sample application to implement this continuous integration. So that's going to be our course plan. And there would be one final class where we will discuss about how these projects are actually explained to the interviewer and everything. And everyday classes would be recorded, and I would be sharing those recorded videos in a Google Drive to which you will get access to. And it would take, the classes would start from Feb 6. The next batch would start from Feb 6 from Marthahalli, that's where I am in. Feb 6 it would be online class. From Feb 7 it would be Marthahalli, because right now I am in hometown. I will be back only on Feb 6. So yeah. So the class would start at 6 a.m. IST. For the first 4 days, it would be 6 a.m. That means February 6th, which is Tuesday till Friday, it would be 6 a.m. IST. Starting from Saturday, it's going to be 7 a.m. and it would be only weekend. Saturday and Sunday, 7 a.m. IST. Only Saturdays and Sundays, 3.5 hours per day. That is the next batch plan. If you want a weekday training, I have a new batch starting on Feb 15th, where you can actually, it would be always Monday to Friday, 9 p.m. IST. Yeah. So these are the two batches that I'm going to start. So I would prefer you joining Feb 6 because that is going to start next week.